Welcome back to our Precalculus 101. For this session, we're going to discuss Module 4, which is all about ellipse. For the objectives for this session, at the end of the lesson, you will be able to define an ellipse, determine the standard form of the equation of an ellipse, and graph an ellipse on a rectangular coordinate system. Let us have this definition. An ellipse is the set of all coplanar points such that the sum of its distances from two fixed points is constant. An ellipse can either be a horizontal ellipse or a vertical ellipse. Now let us have the different parts of an ellipse. The first one are the foci. Foci are the two fixed points of an ellipse, denoted by f sub 1 and f sub 2. If your ellipse is horizontal, then your foci are also graphed horizontally. On the other hand, if your ellipse is vertical, your foci are also graphed in a vertical manner. Now, let us have the major axis. Major axis is the longer axis of symmetry of an ellipse. If your ellipse is horizontal, then your major axis is parallel to the x-axis. Thus, it is also horizontal. While if your ellipse is vertical, then your major axis is parallel to the y-axis. Thus, it is a vertical line. Vertices are the endpoints of the major axis, and they are denoted by v sub 1 and v sub 2. Minor axis, on the other hand, is the shorter axis of symmetry of an ellipse. If your ellipse is horizontal, then your minor axis is parallel to the y-axis, or it is vertical. On the other hand, if your ellipse is vertical, then your minor axis is parallel to the x-axis. Thus, it is horizontal. Co-vertices are the endpoints of the minor axis, which are denoted by w sub 1 and w sub 2. Center is the point of intersection of the two axes of symmetry and is denoted by HK. The vertices, co-vertices, and foci are related by the equation c squared equals a squared minus b squared, where a is the distance from center to vertex, b is the distance from center to co-vertex, and c is the distance from center to focus. If this is your ellipse, your center, one of the vertices, and one of the co-vertices, one of the foci, then this distance is represented by A, this distance is represented by B, and this distance is represented by C. Now, let us have the equation of an ellipse if the center is at the origin. If your ellipse is horizontal and the center lies on the origin, then we use the equation x squared over a squared plus y squared over b squared equals 1. On the other hand, if your ellipse is vertical and the center is at the origin, then we use the equation x squared over b squared plus y squared over a squared equals 1. Let us have the first example. Write the equation of the ellipse in standard form with center at the origin, vertex at 5, 0, and foci have coordinates at positive and negative 4, 0. First, you must graph the given values or the given parts of the ellipse. The center is at the origin. One of the vertices is at 5, 0, and foci have coordinates positive 4, 0, and negative 4, 0. For step 1, we must determine the orientation of the ellipse, whether it is vertical or horizontal. Since the vertex and foci are aligned horizontally, therefore, the ellipse is also horizontal. Thus, we use the equation x squared over a squared plus y squared over b squared equals 1. For step 2, we can now solve for the values of a and b. Since the distance from the center to one of the vertices is 5 units, therefore the value of a equals 5. On the other hand, since the distance from center to one of the foci is 4 units, therefore the value of c equals 4. Now we can use the values of a and c to solve for b. Using the equation c squared equals a squared minus b squared, we can replace the value of c by 4 and a by 5. And 4 squared is 16, 5 squared is 25, therefore we have 16 equals 25 minus b squared. We must solve for the value of b, therefore we write negative b squared on the left side and 16 on the right side. Then we have b squared equals 25 minus 16. And 25 minus 16 is 9. And get the square root of both sides of the equation, or square root of b squared equals square root of 9. And square root of b squared is b, and square root of 9 is 3. Therefore, the value of b equals 3. Using the value of b, which is 3, we can now locate the location of our co-vertices in our graph. Simply locate the points 3 units upward from the center and 3 units downward from the center. For step 3, we can now write the equation of our ellipse. Using our equation x squared over a squared plus y squared over b squared equals 1, replace the values of a and b. Therefore, we have x squared over 5 squared plus y squared over 3 squared equals 1. By simplifying, we have x squared over 25 plus y squared over 9 equals 1. And that is the equation of our ellipse. For step 4, we can identify the parts of the ellipse. Our center is at 0, 0. The two vertices are at 5, 0 and negative 5, 0. Our co-vertices are at 0, 3 and 0, negative 3. The two foci at negative 4, 0 and positive 4, 0. Using those points, we can now graph the ellipse. Now let us have the equation of an ellipse with center at HK, or if the center is not on the origin. If your ellipse is horizontal, then the equation of the ellipse is given by x minus h squared over a squared plus y minus k squared over b squared equals 1. If your ellipse is vertical, then your equation of the ellipse is given by x minus h squared over b squared plus y minus k squared over e squared equals 1. Let us have the second example. Write the equation of the ellipse in standard form with vertices at -2, -8, and -2, 2, and an endpoint of the minor axis at -6, -3. By graphing those points, -2, -8, and -2, 2 are the vertices, and one of the endpoints of our minor axis at -6, -3. For step 1, we must determine the center of the ellipse using the midpoint formula since it is not given on the problem. Using the midpoint formula, x sub 1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2, we're going to use the points of our vertices since the center is at the middle of the two vertices. By replacing the values of the two x's and the two y's, we have -2 plus -2 over 2, -8 plus 2 over 2. We have -4 over 2 and -6 over 2. Therefore, our center is at -2, -3. For step 2, we must determine the orientation of the ellipse. And since the vertices are aligned vertically together with the center, therefore the ellipse is also vertical. Therefore, we must use the equation x minus h square over b square plus y minus k square over a square equals 1. Now, let us solve for the values of a and b. Since the distance from the center to one of the vertices is 5 units, therefore, the value of a equals 5. And since the distance from the center to one of the co-vertices is 4 units, therefore, the value of b equals 4. Now we can use the values of a and b to solve for c. We're going to solve for c for us to locate our two foci of the ellipse. Using the equation c squared equals a squared minus b squared, we're going to replace a by 5 and b by 4. By simplifying, we have c squared equals 25 minus 16. And 25 minus 16 is 9. And getting the square root of both sides of the equation, we have c equals 3. Now we can write the equation of the ellipse using the values that we got from the other steps. Using the standard form of the equation of an ellipse, x minus h square over b square plus y minus k square over a square equals 1, we're going to replace the values of h, k, coming from the center, a, and b. Therefore, we have x minus -2 square over 4 square plus y minus -3 square over 5 square equals 1. By simplifying, we have x plus 2 square over 16 plus y plus 3 square over 25 equals 1. And that is the equation of our ellipse. Now we can identify the parts of the ellipse. Center is at -2, -3. The two vertices are at -2, 2 and -2, 8. The co-vertices are at -6, -3, and 2, -3. Foci are at -2, 0 and -2, -6. And using those points, we can now graph our ellipse.